This is Maria Bertula Sharon from Department of ECE. Here is my case study on topic applications of numerical methods in optimal control problems. Now let's see an introduction about this topic. The concept of dynamic optimization is the natural extension of the theory of static optimization. Some classical examples of static optimization problems are represented by the linear programming, the quadratic programming, the integer or mixed integer programming, and the most famous case of nonlinear programming. In all these problems, the unknown variables are defined over the real or integer numbers r and z. Numerical methods for optimal control problems are classified into three types: direct methods, indirect methods, DPP methods. Mathematical modeling and optimal control problem. The aim for the design of a thermal process for canned food sterilization lies in finding the optimal stream temperature in the sterilization chamber at each time t in order to reach a given microorganism reduction within the can at the end of the process in such a way that energy cost be minimized and nutrient retention maximized. We assume that cans are subjected to a variable stream temperature which will be taken as the control of the system during an interval time OT. Let us consider a can occupying a three-dimensional domain in the red dot. The heat transfer can be modeled by the following initial boundary variable problem. This is that problem where theta is temperature, rho is density, C is heat capacity, K is thermal conductivity, alpha is a heat transfer coefficient to be measured depending in a particular on the tin can. V is the retort temperature. Now let's see the numerical methods used in optimal control. At the heart for a well-found methods for solving optimal control problems are following three fundamental compounds: methods for solving the differential equations and integrating functions, a method for solving a system of nonlinear algebraic equations, and a method for solving a nonlinear optimization problem. Methods for solving differential equation and integrating functions are required for all numerical methods in optimal control. In an indirect method, the numerical solution of differential equations is combined with the numerical solution of systems of nonlinear equations, while in a direct method, the numerical solution of differential equations is combined with nonlinear optimization. Now let's see the methods for solving optimal control problems. The exception of simple problems, for example, infinite horizontal linear quadratic problem, optimal control problems must be solved numerically. The need for solving optimal control problems numerically has given rise to a wide range of numerical approaches. These numerical approaches are divided into two broad categories. Number one, indirect methods, and two, direct methods. The major methods that fall into each of these two broad categories are described in the next two sessions. Now let's see indirect shooting method. While a simple shooting method is appealing due to its simplicity, it presents significant numerical difficulties due to ill conditioning of the Hamiltonian dynamics. The reason for this ill conditioning is that Hamiltonian system have the property that divergence of the flow of trajectories must be constant. That is summation rho divided by rho x into rho h divided by rho lambda plus rho divided by rho lambda into minus of rho h divided by rho x, which is 0. It implies that in neighborhood of the optimal solutions, there exists an equal number of directions along with the solution will contract and expand, and these expansion and contraction takes place at a semi rate. As a result, errors made in the unknown boundary conditions will be amplified as the dynamics as integrated in either direction of time. Here is a schematic of indirect multiple shooting method. Now let's see about direct shooting methods. The most basic direct method for solving optimal control problems is the direct shooting method. The direct shooting method is a control parameterization method where the control is parameterized using a specified functional problem. Here is a schematic of direct multiple shooting. Here, direct methods are classified into two major types: control parameterization and state and control parameterization, which is further classified as shooting and multiple shooting for control parameterization, and local collocation and global collocation for state and control parameterization. In conclusion, a survey of numerical methods for solving optimal control problems has been given of solving optimal control problems has been decomposed into three key components of solving differential equations and integrating functions: solving non-linear optimization problem and solving system of non-linear algebraic equations. Using these components, the two classes of indirect and direct methods for solving optimal control problems has been described. Subsequently, important computational issues have been discussed and several different software tools for solving optimal control problems has been described. Finally, a brief discussion has been given on how to choose a method. Thank you.